Hey, this is lesson 16.4 where we're talking about zero exponents and negative exponents, okay? And starts on page 730 in your textbook if you're following along. So the zero exponents for any non-zero number, a, where a to the zeroth power equals 0, and the power is 0 to the 0 power is undefined. Well, if we look at that, we should be able to come up with that on our own, actually, because if you had something like x to the third power over x to the third power, remember we would subtract these two, which would be x to the 0 power. But we also know that anything over itself equals 1. So we know that x to the 0 power and 1 are the same thing, or they're equal to each other. And we did say when we had this quotient of powers that we could not have 0 in the denominator. So still that applies. Where if you had 0 to the 0 power, we would call it undefined because that would be the same as having a 0 in the denominator. The second thing, negative exponents for any integer and any non-zero number, a to the negative, or whatever it is, to the negative power is the same as the reciprocal of a to that same power, so, or any number. So let's look at this. 7 to the negative second power is the same as the reciprocal, remember that means like you flip the fraction upside down, of 7 to the second power. So 7 to the second power would be just 7 to the second power, but the reciprocal would be 1 over 7 to the second power. So when you have a negative exponent, I always think of it as that means that this is on the wrong side of the fraction bar. And if you just slide it down, or if there was a negative exponent down here, you slide it up, then you just get rid of the negative sign when it makes that transition over. So one other example would be something like 1 over x to the negative third power. Well, this is on the wrong side. That's why it's got a negative exponent. But when you make that transition to the other side, you just take the negative off. And of course, you'd have a 1 down here, but that's the same as just x to the third power. So when you go across the fraction bar, you take the negative off. Okay? Or if I were to bring this down here, we'd put the negative back on. But we don't want to add negatives to our exponents. We want to get rid of them. So looking at the examples here, example 1 says for evaluating expressions, a to the negative fourth is the same as 1 over, 3 to the negative fourth is the same as 1 over 3 to the fourth. And 3 to the fourth is 81 because 3 times 3 is 9 times 3 is 27 times 3 is 81. Same kind of thing here, but we've got negative 8.5 in parentheses, important because of that negative, to the negative fourth power times negative 8.5 to the fourth power. Remember, we would add these two together, which would negative 4 plus 4 gives us 0. So negative 8.5 to the 0 power, which is just 1. Another way we could have done this is this negative 4, remember, means we could have moved this to the bottom of the fraction bar, and then we would have had negative 8.5 to the fourth power over negative 8.5 to the fourth power. Anything over itself, we know, equals 1. So both ways, we would get an answer of 1. And then, example C here, 2 to the 6th over 2 to the 8th is 2 to the 6th minus 8, or just 2 to the negative second power. Because see how the larger power was on the bottom. Okay, so it'll be to the negative second. So we could either do this subtraction, and remember that would give us a negative 2, or we could leave it as a fraction and just 6 of them go away from here, 6 of them go away from here, leaving us with 2 on the bottom, and it would just be a 2 to the second power on the bottom, just a 1 on the top. 2 to the second power is 4, so this is just 1/4. And now let's do the on your own. Those on your own problems. Number 1. 4 to the negative second power. Well, that's the same as 1 over 4 to the second power, which is 1 over 16. Number 2, negative 2 in parentheses to the negative fifth power is the same as 1 over negative 2 to the fifth power. Parentheses still important there to keep that negative on there. And negative 2 times negative 2, well, it's going to be an odd number of negatives. So I know my answer is going to be negative something. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So if I use that 2 as a factor 5 times, I get 32. Negative, of course, odd number of negatives. Number 3, we have 6 to the negative 8th times 6 to the 8th. Two ways I could do this. I could add these two. Negative 8 plus 8 gives me 6 to the 0 power, which is just 1. Or I could have rewritten it as this would 6 to the negative 8 be 1 over 6 to the 8th times 6 to the 8th over 1, which would give me 6 to the 8th over 6 to the 8th. Anything over itself, I don't know what it is, but I do know what these come out to be. But when I put it over itself, it equals 1. So either way, we can see that that would simplify to 1. Number 4, we have negative 3 in parentheses to the fifth power over negative 3 in parentheses to the sixth power. Well, I've got one more negative 3 on the bottom. So when they simplify, I will have negative 3 on the bottom to the first power on the bottom, which I would just leave just like this. And you could, then that would equal just negative 1/3. Number 5, 1 over 5 to the 7th power times 1 over 5 to the negative 4th power. Again, a couple of ways we could do this. I like to try to get rid of these negatives right away, so I'm going to turn this into 1 over 5 to the 7th times 5 to the 4th over 1. See how I just took this, put it up top, and that got rid of that negative for me. Now this becomes 5 to the 4th over 5 to the 7th, just multiplying straight across. I do have more of the 5s that use as factors on the bottom, 3 more in fact. So this would be 1 over 5 to the 3rd. And 5 to the 3rd is 125. So 1 over 125. Number 6, 4 to the 5th power times 4 to the negative 3rd power all over 4 to the 2nd power. So we can bring this, let's simplify on the top here first. If I add a 5 and a negative 3 together, I get 2. So I have 4 squared over 4 squared, which obviously equals 1. Very good. Well, those went pretty quickly. But now we move on to the second example from the book. And this is simplifying expressions. Here we have negative 5 times x to the 0 power. Remember, x, anything to the 0 power, is 1. So this is just negative 5 times 1, which of course is negative 5. Here, the negative 3rd power only applies to that y. Okay? So I could have brought this y to the negative 3rd power to the bottom right away, which is what I would have done. They brought the y to the 5th up top to make it y to the negative 5th, combine them up on top, and then brought them down. Either way, you get 9 over y to the 8th power. Okay? Let's try those on your own, starting with number 7. Number 7 for the on your owns is 8 x to the negative 2. That negative 2 only applies to the x because this is not in parentheses. So that would just be 8 over x squared. 8 over x squared, number 8. We have b to the 0 power times b to the negative 10th power. Well, b to the 0 power is 1. And 1 times anything just is what it is. That's just stays the same. It's a multiplicative identity property. But this b to the negative 10 is really 1 over b to the 10th power. So we'll get that down on bottom there. And that's the final answer because this is just 1 that we're multiplying it by. And finally, number 9 for the on-your-owns. We have z to the 6th power over 15z to the 9th power. And I have more of these z's on the bottom. In fact, I have 3 more. So that will be left with just a 1 on top, 15z to the 3rd power. That 3rd power only applies to the z, not the 15. So you have 1 over 15z cubed. Excellent. So now, because these went so quickly, let's look at the practice and problem solving portion. So number 5, starting with number 5, we'll go 8 to the 7th over 8 to the 7th equals just 1. Number 6, 5 to the 0 times 5 to the 3rd. Well, you could just add these two, which just gives you 5 to the 3rd. We know this is just 1, so really that just stays the same. 5 to the 3rd is 125. Number 7, negative 2 to the negative 8th power times negative 2 to the 8th power equals, because we're going to add these two, which gives us 0. Anything to the 0 power is just 1. And let's look at number 8. And we have 9 to the 4th times 9 to the negative 4th. Same kind of thing. Add these exponents and we get 0. Anything to the 0 power is 1. Let's look at those on the bottom of this page, which starts with number 20. Simplify, and it says write expressions using only positive exponents. Okay, so we have 6y to the negative 4th. This exponent is a negative exponent, so we're not happy with that, but it only applies to the y. So I bring that down on the bottom to make it a positive exponent. Number 21, I have 8 to the negative 2nd power times a to the 7th. Well, this one's good because it's a positive exponent. This one needs to go down below here. So we have a to the 7th over 8 squared. And now that's good, but 8 squared we know is 64. So we can just simplify that to a to the 7th power over 64. Number 9. And by number 9, I actually mean 22. I was just joking you. It has a 9 in the problem, which is probably where I got that. 9c cubed over c to the negative 4th. Well, we don't want that negative 4 as an exponent, so we're going to take that up top, which makes this 9c cubed, and then that c to the 4 comes up here, and we just combine those to get us 9c to the 7th power. And let's do one more, number 23. 5b negative 2 over b negative 3. Well, this negative 3 needs to go up top. This negative 2 needs to come down. So we have 5b to the 3rd over b squared. And now I can subtract these. I have one more on top, so it'll stay up on top. 5b to the 1st power, but I just leave that off, and I don't have to put it over 1. So just 5b. Excellent. Well, you can go and now do whatever the next journal page is. So that would be journal page 382. Journal page 382. Excellent.